Hello everyone. Today we are going to learn about the freeze drying. This freeze drying is also called as lyophilization, sublimation drying, and cold drying. This is a stabilizing process in which substance is first frozen and then the quantity of solvent is reduced. So how it is going to get reduced? First one, it is by the sublimation process, which is called as a primary drying. And then it will be reduced by desorption process, which is also called as a secondary drying. It will be reduced to up to that value which will no longer support the biological activity or chemical reaction. This freeze drying is solvent loving system. So using the freeze drying process, we can always recollect the solvent which we have used. But what is sublimation? You might have come across this word sublimation in your 11th and 12th science. So sublimation, before we are going to study the same, you might have seen this particular graph. In this graph you can see that this is the pressure, this is the temperature, and at this particular pressure and temperature, what will be the state of that particular material? It will be either in a solid, liquid or gas. But this is the one of the point which is called as triple point, and in this point your material will be in a solid, liquid and gaseous in all these three states. So sublimation is a transition of a substance directly from the solid to the gas state without it is going to get converted into the liquid state. So that is what the sublimation is. But what is lyophilization? Lyophilization, it is also called as cryodesiccation. It is a low temperature dehydration process. So in this, water will be removed at a lower temperature. This involves freezing the product by lowering the pressure and then removing the ice by sublimation process. Over here you can see a freeze dryer. The left side one is a laboratory scale freeze dryer. And on the right side you can see the larger scale freeze drying process has been taken place in the bigger freeze dryer. This freeze dryer is also called as lyophilizer, as the lyophilization process or freeze drying process or sublimation drying process or cold drying process is taking place in this particular dryer. Now we will see the principle of this freeze dryer or lyophilizer. As we know, when liquid gets evaporated, it will convert it into the gas. When gas is condensed, so that it will be converted into the liquid. When liquid is freezed, it will convert it into the solid, and solid, when it is going to get melted, it will be converted into the liquid. But when solid is sublimized, it will directly convert to the gas without transferring into the liquid, and gas will deposit it directly into the solid. So the principle of freeze dryer depends on this particular process which is called as a sublimation. So as we have discussed, at particular temperature and pressure condition below the triple point, the solid will going to get converted into the gas without transferring into the liquid. So that is what the principle of this freeze dryer. Now let's see some of the essential components of this freeze dryer. First one is a drying chamber. So this drying chamber is a tightly insulated box made up of stainless steels, which also contains different shelves or the trays. These shelves or trays are going to be helpful to keep our material which we want to get dried. It also works as a heat exchanger. Then next component which is required is a refrigeration system, which is going to cool down or convert our solvent into the ice. Then next is a condenser. A condenser is a coil or plates for trapping the solvent vapor. And last one is a vacuum pump or steam ejector or we can use both the vacuum pump and steam ejector in the freeze dryer. So these are some of the essential components. If we move towards the working of freeze dryer, then the freeze dryer working can be divided into different steps. First one is preparation and pre-treatment. Second is freezing stage. Third is primary drying stage. Fourth one is secondary drying stage. And last one is a packaging. So now let's learn that what will happen in the preparation and pre-treatment stage. In this stage, we are going to concentrate our product. How we are going to do this? By removing the excess solvent or water. As we know, the satisfactory freeze drying beyond a certain limit of depth of liquid is not possible. Means, if the liquid is in more amount, the freezing cannot be possible at certain depth. Means, अगर liquid ज़्यादा हो गया, we will not be able to freeze it properly. So that is why the pre-treatment is very much required. And because of this pre-treatment, we are going to increase the surface area. Next stage is freezing stage. The product is frozen into ice in this stage. Means, as the name suggests, freezing the stage. So in this, we are going to freeze our product into the ice. Over here, eutectic mixtures are sometimes used. These eutectic mixtures having a freezing temperature below to that of an individual component. So the product can be frozen at -10 to -30 degrees centigrade at this particular stage. The next stage is a primary drying stage. In this primary drying stage, they are saying that the temperature and pressure are kept below the triple point. So if we want to dry our product directly from the ice to the gas, we need to keep a temperature and pressure below the triple point. So the solvent or water present in the ice form will directly convert it into the gas form. So usually the temperature is 0.0098 degrees centigrade and pressure is 0.533 kilopascals. This one is for the water alone. If the water alone is present as a solvent, then and then only this temperature and pressure is going to be helpful to keep your temperature and pressure below the triple point. But if other solvents are there, we need to identify the temperature and pressure at which the triple point will be there for that particular solvent. So at this stage, at the primary drying stage, 90 to 95% of water will be removed. And the time duration take place to remove this 90 to 95% water at the primary drying stage, it is 20 to 24 hours. The next stage is a secondary drying stage. This one is also called as a isothermal desorption. In this stage, we are going to continue with the same pressure, but the temperature that we are going to gradually increase. And that temperature will be increased up to 10 to 40 degrees centigrade. This secondary drying stage is going to take place for 8 to 10 hours. And this stage will remove the bound water. And the last stage is a packaging. So once primary drying and secondary drying is complete, so most of the water has been removed from our product. So drying is complete, so the vacuum is placed by an inert gas and ampoules are sealed with different sealing methods, or vials or bottles are sealed with rubber closures or aluminum caps. So at the end of this freeze drying, by using the freeze dryer, we are going to also pack our product into the final stage. This is a diagram of a freeze dryer. In this you can see there are various perforated plates placed in the freeze dryer. These perforated plates will be helpful to keep our samples. This freeze dryer unit is connected with a heating system, refrigerator unit, as well as the vacuum pump and ice condenser. So these plates are having perforation. Why is it so? Because we want to make sure that whatever the heating system is going to provide the heat and whatever the refrigerator unit is going to provide the coldness, that particular heat and cold waves should be reached to the upper plates. So if the perforations will be there, it will be easier to reach this particular heat as well as the cold waves to the topmost perforated plate. Now what will happen, that first of all we are going to start the refrigerator unit, and with this use of refrigerator we are going to make our solvent into the ice form. We are going to convert our product which is having a solid as well as the liquid, and we are going to convert that particular liquid into the solid form by using the refrigerator. So the liquid will going to get converted into the ice. Then we are going to apply the vacuum pump. We are going to apply the vacuum. So pressure will be reduced, as well as we are going to heat the system using the heating system. So with that use of heating system, we are going to increase the temperature. So as the pressure is going to get reduced and temperature is going to get increased, the solvent which is present in a solid state, it is directly going to get converted into the gas, and that gas is going to get collected into the ice condenser. This ice condenser is going to convert that gas directly into the ice, and that ice is going to be get collected with the drainage system. In this way, our whatever solvent was present, we have converted into the solid, and it will be directly converted into the gaseous form. And with the ice condenser, we have also collected our solvent back. So we have recovered the solvent. So that is the procedure of the freeze dryer. Now we will see different uses of freeze dryer. It is used in a vaccines and antibodies preparation, penicillin, blood plasma, protein, enzymes, bacterial and viral cultures, human tissues, plant extracts, steroids, vitamins and food items can be freezed and dried using the freeze dryer. Now let's see the advantages of freeze dryer. So the advantage includes, it is helpful to dry the thermolabile material. The product containing a bulk volume can be dried with this freeze dryer. Reconstitution of material is very easy with the freeze dryer. Denaturation does not occur in this, as well as the loss of volatile material is very less in this particular freeze dryer. Not only this, the moisture level can be kept as low as possible without any kind of decomposition when we use the freeze dryer. Material can be dried in its final container, such as single dose and multiple dose vials, as we have seen in the process that the product will be directly packed after the drying process. So material can be get into the final container. The sterility can be maintained, as well as the final product can be stored at ambient temperature if well sealed by providing the inert atmosphere by passing the inert gas into that particular vials or bottles. Now if we talk about the disadvantages of the freeze dryer, then the freeze dryer is a costlier one. Its maintenance and equipment cost is higher. It occupies lots of space, as we have seen in the picture. The transportation of frozen material can be difficult as well as expensive, and failure of any kind of freezing equipment would risk a total loss of the product. So these are some of the disadvantages of the freeze dryer. And with this, we complete the understanding of a freeze drying. I hope you understand the same. Thank you so much.